Okay, this is solving exponential equations. So first we're going to talk about the property of equality. It says if b is a positive real number other than 1, then b to the power of x is equal to b to the power of y if and only if x equals y. What this is saying is that if our bases match, we can cancel them out and bring down the exponents. So in the example, it says if 3 to the power of x is equal to 3 to the power of 5, so notice our bases are the same, they're both 3's, we can cancel them out and we are left with just x equals 5. Okay. So that is what we're going to do for the first couple examples. So looking at example 1, we have 2 to the power of x plus 6 is equal to 2 to the power of 5. So what I can do is cancel out the bases of 2 since they match, and I'm left with x plus 6 is equal to 5. Solving for x, I can subtract the 6, and I get x is equal to -1. What's nice about exponential equations is that we do not have to check our answers. And that's because down here it says because an exponent can be any number, negative, 0, fraction, positive, etc., there are no possibilities for extraneous solutions. So remember, extraneous solutions mean that if we plug it in, we either get a false statement or we get something that just does not work. So for these ones, we do not need to check. So number 2, notice that we have the same bases, so of 4, which means I can cancel them out, and I have 3x plus 4 is equal to -2x plus 1. Now I just solve for x. So if I add the 2x over, I'm left with 5x plus 4 equals 1. Subtract the 4, 5x is equal to -3. Divide by 5, x is equal to -3/5. That's my answer. Number 3, notice that I no longer have the same bases. So in order to do this, I need to first change the bases where I can get 9 and 27. Typically, the bases we use are 2 and 3. Well, I know that 3 squared is the same as 9, and 3 to the third power is the same as 27. So I'm going to replace that and rewrite this as 3 squared, bring down the 2x minus 5, is equal to 3 cubed. Well, now my bases of 3 match, so I can cancel them out, and I'm left with 2 times 2x minus 5 is equal to 3. Distribute the 2, I have 4x minus 10 is equal to 3. Add the 10, 4x is equal to 13. Divide by 4, x is equal to 13/4. That's my answer. Number 4. Okay, so notice here are my bases. I have a base 4 and a base of 1 over 32. Well, I know that 2 squared gives me 4, and 2 to the 5th power gives me 32. But since I want the fraction 1 over 32, I have to change that exponent to a -5 to get 1 over 32. So then I exchange them for the original bases. So 2 squared, bring down the 2x plus 3, is equal to 2 to the -5th, bring down the 3x plus 1. Now my bases of 2 match, and I'm left with 2 times 2x plus 3 is equal to -5 times 3x plus 1. So that's 4x plus 6 is equal to -15x minus 5. I can subtract the 6 over, so 4x is equal to -15x minus 11. And add the 15 over, so 19x is equal to -11. And divide by 19, x is equal to -11 over 19. That's my answer. Number 5, here are my bases, 32 and 4. I know that 2 to the 5th power is 32, and 2 squared is equal to 4, so I'm going to exchange them for those powers. So I have 2 to the 5th power, bring down 4x minus 1 over 5, is equal to 2 to the 2nd power, bring down 3/2 x squared. Well, my bases match, so I can cancel them out, and I'm left with 5 times 4x minus 1 divided by 5 is equal to 2 times 3/2 x squared. Well, notice 5 divided by 5, those cancel out, and 2 divided by 2 cancel out, so I'm left with 4x minus 1 is equal to 3x squared. Well, since I have an x squared, I know that this is quadratic, so it has to be equal to 0. So I'm going to move these over to the other side, and I get 3x squared minus 4x plus 1 equals 0. So I need two numbers that multiply to 3 but add to negative 4. And those two numbers are negative 1 and negative 3. So I rewrite this as 3x squared minus 3x minus x plus 1 equals 0. I do my factor by grouping and take out a GCF. So I can take out a 3x and I'm left with x minus 1, and take out a negative 1 and I'm left with x minus 1. So I have 3x minus 1 and x minus 1 equals 0. I set them separately equal to 0, so 3x minus 1 equals 0 means x is equal to 1/3. And then x minus 1 equals 0 means that x is equal to 1. So I have x is equal to 1 and x is equal to 1/3. Two answers. So that was the first part of the notes. Now let's say we get to the part where there are different bases. So that means I am not able to change them to match them up like I did in the first part. Well, in order to do that, we are going to have to change those exponentials into logarithms. So remember, in order to do that, we circle the base, so that's our 5. I loop around and point to the exponent, which means this is the same as saying log base 5 of 18 is equal to x minus 3. Well, log base 5 of 18 is just a number, and I'm trying to solve for x. So I can just add 3 to the other side, so x is equal to log base 5 of 18 plus 3. And if I wanted to get the approximation of that, I would plug this into my calculator, and that would give me x is approximately 4.796. Number 5. Same thing. I circle my base, loop around, and point to my exponent. This is the same as saying log base 8 of 205 is equal to 4x plus 1. I subtract the 1, so log base 8 of 205 is minus 1 is equal to 4x. And then I divide by 4, so x is equal to log base 8 of 205 minus 1, all divided by 4. This is the exact answer, and if I wanted to get an estimate, then I would plug this into my calculator, and I get x is approximately 0.3899. Number 6. So for this one, now I have this in terms of e. So I can't just turn this into a logarithm. I have to remember that e and natural log cancel each other out. So what I'm going to do is I'm going to take the natural log of both sides. So the natural log of e to the 4x minus 9 is equal to the natural log of 56. Well, natural log and e cancel each other out, so this is 4x minus 9 is equal to the natural log of 56. Well, the natural log of 56 is just a number. So if I'm solving for x, I can add 9 over, so 4x is equal to the natural log of 56 plus 9, and then divide everything by 4. This is my exact answer. And if I want an approximation, I would plug that into the calculator, and I would get x is approximately 3.2563. Okay, number 7. So notice here, again, I have e. So right away, I know I'm going to be using the natural log again. But notice that my exponential is not by itself. It has a negative in the front and a -1 in the back. So first I have to get it by itself. So I'm going to add 1 to the other side. So negative e to the negative 3.9x minus 1 is equal to negative 2. And then I'm going to divide both sides by a -1, and I get e to the negative 3.9x minus 1 is equal to 2. Notice that the exponent did not change. Then I'm going to take the natural log of both sides. The natural log and e are going to cancel, so I'm left with negative 3.9x minus 1 is equal to the natural log of 2. I'm going to add 1, so negative 3.9x is equal to the natural log of 2 plus 1, and then divide by negative 3.9. So x is equal to the natural log of 2 plus 1, all divided by negative 3.9. That is the exact answer. If I wanted approximation, I would put it in my calculator, and you should get x is approximately negative 0.4341. Okay, last one, number 8. Okay, so again, we have to make sure that whatever we're dealing with is by itself. So this base, 18 to the 6x power, has a 5 in the front and a plus 9 behind it. So I have to subtract the 9. So 5 times 18 to the 6x power is equal to 26. Divide by 5, so I get 18 to the 6x power is 26 divided by 5. And now I can turn this into a log by circling my base, wrapping around, and pointing to my exponent. So this is log base 18 of 26 fifths is equal to 6x. And then to solve for x, I'm going to divide both sides by 6. So x is equal to log base 18 of 26 over 5, all divided by 6. And that is my exact answer. And if I needed an approximation, I would put this exactly how it is in the calculator and get x is approximately 0.0951.